Okay, quick synopsis. For the function we see here, we can find the x and the y derivatives of the function at the point pi over 2, 3, and we get approximations to the exact values as we see here, so that when we move in the y direction, the value of the function changes as we move in the y direction, and it changes at a rate of 28 units of change in f per unit of change in y. And left an x off of here, and that's kind of compressed, but moving in the x direction, our rate of change is approximately 16 units of z change for every unit of x change. And those rates are going to be pretty close if we just stay in the immediate neighborhood of this point. We see how x changes with respect to x and with respect to y, and I just saw another, no, never mind, thought I saw an error, I didn't. Okay, so we know how f changes if we move in the x direction, and how it changes if we move in the y direction. If we move by small distances, these are the pretty close to the rates of change. Just where are we? What is the value of z at the point pi over 2, 3? Well, it's easy to plug the points in here and get the value, and I've already done that. At the point pi over 3, 3, f of x, y is fairly easily evaluated. We get 9 pi squared plus the square root of 3, and I'm going to say that's about 270. Actually, I know I'm off by that because pi squared is greater than 9. It's actually closer to 10, so that the 270 should probably be closer to 300. So I'll put a little question mark and exclamation sign there to show that this is a very rough approximation and it wasn't a very good mental approximation. Still, we're going to just take that value. If you want to do accurate analysis in this function, you can easily plug in the right numbers. Now, in x, y, z space, then we have point what? X coordinate, y coordinate, z coordinate. Well, we have pi over 2, 3, 270. And actually, I was going to write down the exact value. This is an approximation of the value pi over 2, 3, 9 pi squared plus the square root of 3. Let's depict that point. And we know, reviewing what we had or repeating, that fx is about 28, fy is about 16, fx is the rate of change of f with respect to x, fy the rate of change of f with respect to y. Now we can't really graph this using a consistent scale, but we can say, okay, x is pi over 2, that's about 1.6. And that's going to be the coordinate of the point on the x-axis. The coordinate of the point on the y-axis is going to be 0, 3, 0. In other words, y is going to be about 3. And that notation isn't real consistent with this. We can say that that point is approximately then 1.600. And this distance here is going to be the value of our function, and that's going to be 270. Now obviously this 270 is not measured in the same scale that the 1.6 or the 3 is measured. Still, we have this point on the graph. If we move to the point, let's say pi over 2 plus 0.1 and 3.05, what is the change in the value of our f function? Of course, we could plug these numbers into the formula for the function and compare with this figure here and calculate the change. But what we're trying to do is get a picture of the three-dimensional behavior of the values of this function with respect to the values x and y. Now I'm going to exaggerate a change in x. Now if we move in the x direction, if we move in the y direction, if we hold x steady and move in the y direction, then remember that this thing is going to have a slope of about 28. So if we were to depict this we could depict this rectangle in the plane parallel to the YZ plane, and we'd see that the slope is about 28. If we move in the x direction, and I think I just got that wrong, the slope in the y direction would be 16. Let me see if I can get rid of that 28. The slope is about 16 here. Now if we move in the x direction, we move this way, and we can again sketch this part of a rectangle, and it's a little steeper, so let's just put it about here and say that this slope, if we do a segment here, and remember the x direction is parallel to the x-axis, so it's like this, so that this slope is about 28. Now you can quarrel with my labeling here, and I would too, but I'm not going to redo this right now. So if we move 0.1 unit in the x direction, if this is 0.1 unit here, then what's this change? This delta F would be approximately slope, which is 28, times 0.1, or 2.8. So that by virtue of moving 1/10 of a unit in the x direction, we would move 2.8 units in the z direction. Now if we move 0.05 units in the y direction, which we do if we start at the point pi over 2,3 and move to 3.05, then this distance here, and we'll depict that by an arrow in the y direction, this distance is 0.05. If we move 0.05 units in the y direction, then of course this distance here will be 0.05. This slope is 16, and the rise divided by the run has to equal 16, meaning the rise has to be 16 times as great as the run. So the rise is delta F approximately equals 0.8. 16 times 0.05. That would be Fy delta y, which is 16 approximately times 0.05, giving us a delta F of about 0.08 due to our y motion.